Section 4.3 is all about polynomial function graphs and their graph composition. So here's a polynomial function of degree n, its formal definition. We have seen this before. What is really unique about functions is if I add two functions, the sum is also going to give me a function. So remember a function, each x has unique y values. If we're looking at the graph, they pass the vertical line test. The example I used in class was a vending machine. So if I'm given two functions, I can find the sum of those two functions. And it's just going to be done by adding those together. So f plus g of x, that's a typo there, sorry, equals f of x plus g of x. And I'm really just going to add these together and combine like terms. So f plus g of x would be f of x plus g of x. And I combine like terms, so I have x squared plus 3x plus 6. So this is a degree 2 trinomial. And if I want to find f plus g of 2, I'm just going to substitute 2 in to f plus g. So this would be 2 squared plus 3 times 2 plus 6. So that's going to give me 4 plus 6 plus 6, which is 16. So f plus g of 2 is 16. If I can add functions and find their sum, I can also find their difference. So if I want to find the difference of two functions, I'm going to be subtracting one from the other. So let's say we still have f of x equal x squared plus 1 and g of x equals 3x plus 5. I'm going to take x squared plus 1 minus, and be sure you use your parentheses so you don't forget to distribute, 3x plus 5. This equals x squared plus 1 minus 3x minus 5. So I have x squared minus 3x minus 4 is the difference of our two functions f and g. In order to find f minus g of 1, again, I'm substituting 1 in for x. This is a function defined in x. X is our independent variable. So I have 1 squared minus 3 times 1 minus 4. That means 1 minus 3 minus 4. 1 minus 3 is negative 2. Negative 2 minus 4 is negative 6. Where things get a little more complicated is when it comes to function composition. So if f and g are functions, then the composite function of f and g is defined by taking f composed with, that's how I'm going to read this, composed with g of x. What that means is I'm substituting in g of x for x in f of x, okay? And the domain of the set is all real numbers in the domain of g, such that g of x is in the domain of x. What does this even mean? Okay, so let's define two really simple functions. Let's use linear functions. If I have f of x equals 3x plus 1, and I have g of x equals negative 2x, what I'm going to go ahead and do in order to take the composition of f composed with g of x is I'm going to take f of g of x. That means I'm substituting g of x in for x in f. So I'd have 3 g of x plus 1. I'm then going to substitute in g of x, which was negative 2x. So I have 3 negative 2x plus 1. That's going to give me negative 6x plus 1 is my function composition. Okay, now these were both linear equations, so their domains are both negative infinity to positive infinity. So that means the domain of my function composition is also going to be from negative infinity to positive infinity. So let's go ahead and do another example. This is a little more, we've got a little bit harder equations here, right? Because I've got a degree 2 equation. This graph's going to look like a parabola. Both of these, though, have domains of negative infinity to positive infinity. So my composition's also going to have a domain from negative infinity to positive infinity. Let me go ahead and write that down. So if I'm going to take f composed with g of x, that's f of g of x, which would be f of x except with g of x substituted in. So I'm going to have g of x squared. That's x plus 3 squared. And remember, if I'm squaring a binomial, I need to FOIL this out. So I'm really have x plus 3 times x plus 3. That's going to give me x squared plus 3x plus 3x plus 9. So I've got x squared plus 6x plus 9 is f composed with g. So this is a degree 2 trinomial, but its domain is still from negative infinity to positive infinity. So let's go ahead and find f composed with g of 2. So I'm going to be substituting 2 in for x squared. So that's going to give me 2 squared plus 6 times 2 plus 9. So I'd get 4 plus 12 plus 9. That's 16 plus 9, which is 25. So another way you could do this, if you didn't want to calculate f composed with g of x, is you could take f of g of 2. So that would be f of g of 2, which would be 2 plus 3, which would give us f of 5, which would be 5 squared, which is 25. And you would get the exact same answer. All right, let's do another example. This time I'm doing g composed with f. What that means is I'm going to be taking in f of x and substituting in for x in g. So I've got f of x squared plus 5. Well, that's going to be 4x minus 1 squared plus 5. And I have to FOIL this out. So I have 16x squared minus 4x plus 1 plus 5. So I would get 16x squared minus 8x plus 6. Now, in order to find f composed with g of x, I could do it either by substituting negative 2 into this function, or I could solve for g of f of negative 2. Either way, it'd be equivalent. So g of f of negative 2, that's going to be 4 times negative 2 minus 1. That's going to be g of negative 9, because 4 times negative 2 is negative 8, minus 1 is negative 9. And then I'm going to have negative 9 squared plus 5. So I get 81 plus 5, which is 86 for my final answer.